This is a video about string theory and how it dominated science and physics media for like 30 years. And as a direct result of that, science communication is really hard now because they lied to us. They lied to us for 30 years and now we have to pick up the pieces. And I don't want to talk about string theory. I don't want to talk about the science, the math, all the stuff involved in string theory. I want to talk about the public response. If you want to learn string theory, you can just go buy a textbook like this one. This guy's a big guy in string theory. He can teach it to you. It's fine. I want to talk about the public response and the duty we have as professional researchers to communicate science accurately. And to distract me from doing the science, I'm gonna play a game while I talk. And I've never recorded a video in a single sitting, so I hope it goes okay. So to talk about string theory, we have to describe it. We have to talk about the science like a little bit. I'm playing as normal, don't judge me. So string theory first came out in like the 50s, the 60s. There was a problem with protons and neutrons. When we started hitting them with stuff, protons and neutrons started acting like they had shape, like they had structure. Like rather than acting like a point particle, a proton would act like a sphere. So when you hit something off of it, it would act as if it depended on where on the body of the proton you hit it, which means it has structure underneath it. And so string theory came about as like, well, maybe fundamental particles at their very basis level are strings, one-dimensional, very, very small strings. So like if we look at them on the scale, we look at particles, they look like point particles, but really they're strings and they can curl up and they can change shape and they can change where they move in the dimensions. And however they do this is how they determine the charge and spin and mass of a particle. Neat. This theory was very unsuccessful because, this theory was unsuccessful because of QCD. The theory of quarks comes out, and quarks work really well to explain what we see going on in protons and neutrons. So this becomes the standard model of physics. The standard model is a very, very successful theory of physics. Let me explain what a successful theory of physics does. The first thing is that a successful theory of physics has to have some mathematical rigor. It has to explain with a theory, with an idea, an understanding of what is going on in order to describe observations. So the standard model says, okay, protons are made up of quarks, and when you slam neutrons into protons, here is what happens. We can calculate the trajectory of these particles. We can calculate the mass of these particles. That's what a very successful theory of physics will do. The second thing it will do is it will explain all previous observations. So everything that we have observed and we have seen to be true needs to be explained by a theory in order for the theory to like take hold. So the standard model can explain all the things we've seen with quantum mechanics so far, and everyone's happy with it. It explains what the protons are doing. And the third and final thing, well, I mean, not final, in my opinion, the third most important thing a successful physics theory will do is make predictions. So the standard model is probably one of the most successful theories ever in that regard, in that it predicts particles that should exist that had not yet been observed. So the standard model says at this energy level, we should see a W boson. And in 20 years, when they get the funding and the expertise to build the particle accelerator to do that experiment, what do you know? They find the W boson. They did it. And they've done that with more than one particle. I think the Z boson, the tau, there's like a pi meson. All of those were predicted before they were discovered and observed. The most famous is probably the Higgs boson, which was predicted in like the 70s and found in 2012. That is a very, 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 very successful working model of physics. It made a prediction and we found the thing. I'm not good at this game. However, you know, there are failures of the Standard Model. The biggest failure, in my opinion, is dark matter. The Standard Model is supposed to be this theory of like the smallest masses of particles, and it doesn't have a good candidate for a particle that will make up dark matter. And maybe that makes sense because, as I said, or have I said, maybe that makes sense because the Standard Model doesn't have gravity in it, right? It only has the strong, the weak, and the electromagnetic forces. So maybe that's why it doesn't have a dark matter particle, but it doesn't have a dark matter particle. And you can't be a theory of particles and then also be like, well, we don't know what the dark matter particle is, even though it's 90% of the mass of the universe or whatever. So that's a problem. But I think a bigger problem for people is that the Standard Model doesn't include gravity. Oh, that's why I was gonna say it. It's on my list here. The Standard Model doesn't include gravity. People don't like this. People want one big, beautiful theory of everything, a gut or a toe. They want to explain absolutely everything with one theory of physics. And the fact that the Standard Model fails to include a quantum gravity means that it is wrong, in some people's opinion. Or maybe not wrong, but it is a placeholder that will be superseded by the actual theory, the correct theory, whenever that happens. The same way Einstein came and replaced Newton's ideas about gravity. Something is going to happen to the Standard Model to fix it, in their opinion. And that's when string theory comes back. String theory comes back in the 70s and 80s as a suggestion of, well, string theory can explain gravity. So, haha, we just have to wrap it backwards and make string theory explain particles, and then we have a theory of everything. Oh my goodness. So, yeah, now let's talk about string theory. I want to do it historically, like a timeline. I don't have any keys. So I'm going to start in the 80s, and I'm going to do it through three perspectives. So what the string theorists were doing in the 80s, and then what the public was doing with string theory in the 80s. And when I say public, I do not mean that in like a negative way. I mean people who are not working physicists, but, oh, I don't have any keys, but they are interested in physics. So like someone who is gonna get on a 4-hour plane ride and they go to the airport bookstore and they walk right past the Colleen Hoover and they go straight toward, I don't read popular science books that much anymore. I don't know what's popular right now. They go straight towards whatever people are reading now in the popular science category. And they're like, yeah, for a little bit of time today, I am gonna learn about dark matter or cosmology or condensed matter theory or whatever the popular science books are talking about today. Those are the people who were interested in string theory. And those make up the majority of people who are interested in physics because what do you know? Most people are not professional physicists. So the public are the people who receive information about science. Ooh, I don't want that. They're people who receive information about science from scientists who give them that information. And because that is most people, that is the most amount of people who understand science at any given time, right? Your popular science readers make up the biggest faction of people who are interested in understand physics. And then the last group will be just other physicists, just all the physicists that are not string theorists at the time. And we will go through the 1980s to now-ish. We don't need to go to now, though. Spoilers for string theory. Excuse me. Okay, so string theory comes back, baby. It's like, hey, we could explain gravity, and that's the 1980s. There was the first string theory revolution in 1984, and they're like, we can explain gravity, and we have this theory that works in multiple dimensions. And so if you know anything about string theory, you might know that you require more than one dimension. There were some theories with like 8, some with 11, some with 30 or 28, all kinds of different string theories. And I think now, don't take my word on this, I think now you need at least 11. I'm not sure, but string theory comes out and it's like, hey, we're working in these multiple dimensions. Like instead of just having 4 dimensions, you know, X, Y, Z, and time, we have multi-dimensions, and using this, we can explain a theory of quantum gravity. And everyone's really excited about this. We're talking about the string theorists in the 80s, and the number of string theorists, like starts getting huge. Like, people are very, very interested in string theory, and they're like, this is amazing. Ed Witten, who's a big, big string theorist, has this quote where he's like, this is an amazing theory. It's a 21st century theory that fell into the 20th century, because remember, it's the 80s. And Ed Witten is really big in string theory. He wins the Fields Medal, which is a math award. And I think he's still the only physicist ever to win a math award. That's how good this guy is at math. And he's working on string theory. And let's skip to the public, because string theorists start giving all these interviews. And Ed Witten's one of those interviews. He was profiled in the 80s. And the whole profile keeps calling him like the next Einstein. It's hard to do this while I'm fighting a boss. They keep calling him the next Einstein, and Ed Witten's like, oh, no. But immediately, as soon as string theory comes out, the press is reporting it as like, we're living through another physics revolution. It's as if we're living in the 1920s. Ed Witten is Albert Einstein. Something I find really funny is that string theory was introduced by the public, to my estimation, by Gary Taubes in 1985. Do you know Gary Taubes? He does all those fitness books. But he is one of the people responsible for this mess with string theory, because he introduced it to the public. I have to scroll down on my notes. The public, though, they're usually like 10 years behind. So if string theory started gaining traction in physics in the late 70s, the public started hearing about it in like the mid 80s. And like I said, the public are people who are interested in physics, who are interested in learning cutting edge physics and like being a part of it. So they are very excited to hear from physicists who say, this is it. Like in a decade, we're going to have crazy new results. This theory is going to change everything for us. And when they compare it to quantum mechanics in the 1920s, the people, the public who are interested in physics, are very, very excited. So the public is waiting. Oh, that wasn't worth it. Is waiting for like the next Einstein. They are ready to live through an Einstein, and they're very excited. And you have to think about, if someone is 30 in the 1980s, that means like they grew up and watched the moon landing. They grew up and watched like the internet appear. I guess it's the 80s. Yeah, so they're hearing about the internet in the 80s. They understand what it means when people say, oh, this is going to be like Einstein. This is the next big thing. And I think that's important to remember. These people are not dum-dums. These people are excited to live through an amazing historical time in physics. And they think string theory is going to do that for them, because the string theorists are saying it. In the 80s, the physicists are like, huh, this is really neat. I'm excited about this string theory. Remember, they called it the first big revolution in string theory. They're like, we can explain quantum gravity, or a type of quantum gravity. And a bunch of physicists start going to work in string theory. They're like, this is exciting. You know, more physicists are working in string theory, and departments across America, I'm sorry, I'm always really American-centric, are hiring string theorists. They're like, oh no, this is the next hot thing. Like, we're the University of Illinois. We need to get a string theorist in here. And there's a very funny thing that happens in like academia, where a thing becomes the new hot thing. And so every single grad student who just happened to decide to work in string theory in the 80s suddenly gets a faculty position right out of grad school, right? And that's kind of cool. Right now, I don't know, like I guess like 4 years ago, it happened with machine learning. Like, everyone who just happened to learn machine learning in graduate school, it's like, oh God, we all need a machine learning guy. Quick, hire all the machine learning guys. And if you're in grad school right now, I'm sorry, you can't predict it. You can't predict what it's gonna be. Like, good luck. I hope you chose to do machine learning 8 years ago and now you're a professor, if that's what you want, but you probably don't want that. So there's like this big hiring boom in string theorists, and people are talking about string theory, and they're like, in a decade, they said, it's gonna happen. In a decade, we're gonna get there. It's gonna be amazing. And then we can move to the 1990s. In the 1990s, from the string theorist perspectives, something amazing happens. In 1995, Ed Witten, I've mentioned him, he comes to a conference with a paper, and he's like, guys, we have all these theories of string theory. They're all multi-dimensions, they're all different dimensions, but listen, I have done the math. This is Ed Witten talking. He says, I've done the math, and it turns out you can move between these theories. They're actually all the same theory. If you watched my mass video, I talked about Lorentz transformations between reference frames. Like, you can just do a conversion and go from one reference frame to another, and you can do the same physics. That's a similar thing here. Ed Witten is like, all of these string theories are the same string theory. This is amazing. And the public, no, the public, the audience at this conference is like, this is amazing. This is a validation of string theory, because like I said, people, they want physics theories to be beautiful. And the idea that you need 10 different string theories is not beautiful, but the idea that they're actually all the same string theory is very beautiful and very exciting. So the string theorists see this as like a confirmation of their theory. It's not. It's a very interesting mathematical tool and idea, but it's not a confirmation of string theory, but it's fine. They're like, this shows you, they think, this shows you that we are working towards something real, because all of these theories are the same theory. And this is called the second revolution in string theory. And like, I mean, they're playing really fast and loose with the term revolution. If you haven't had a single experimental verification, can you have multiple revolutions in the same theory? I don't understand. But this is the second revolution in string theory. And they're like, you guys, in a decade, big things are gonna happen. And another thing that happens in the 90s is the development of supersymmetry, which again, I don't want to go into, but all the forces freeze up into one force. You can use one theory to explain all the forces, and it's symmetric and it's beautiful, because that's important to us. That's in the 90s. The public is when it's the 90s when it starts getting serious. The public, again, not like your general public, but like people who are interested in following physics are like, this is it. We're living in a revolution. Like, the next Einstein is here. Who's it gonna be? And this is when you start getting celebrity string theorists. People like from that group of professors who was hired in the late 80s, you know, like, like your Brian Greens and all those people who they're writing books, they're becoming celebrities, and they're writing their hyperspace books and their Elegant Universes. I don't know when that one came out. I read them all. I don't know if you can tell, but I was the public. I was the public in the 90s. I was reading all these books, and I was like, string theory is it, babes. So you get, ooh, I don't want that. You get these celebrity string theorists, and they're writing their books, and they're going on talk shows, and they're going on talking tours, and they're giving these big public talks, and they're making lots and lots of money telling an enchanted public about how string theory is a revolution in physics, how string theory is gonna change the world. The public needs to know about string theory. Just wait 10 years, babes. It's all coming. The big things are gonna happen. We just need a decade to figure it out. It's gonna happen. And in the 1990s, the physicists, the other physicists are like, all right, you said a decade. It's been a decade. What's going on? What's going on? And this is when the physicists, the experimental physicists, realized that string theory is not testable, right? Like, you have all these dimensions. Like, we can't actually observe all these dimensions. Like, how could we ever test this theory? In fact, is it a theory? Is it a theory if you can't test it? Is it a theory at all if it is experimentally unverifiable? And this is when it kind of, the physics community is kind of like, well, okay, like, do your strings, but like, this isn't the hot new thing. Like, by the 90s, it's no longer like we need a string theorist to headline our physics conference. They're not hiring string theorists anymore. Every department's like, well, we have one. Surely we don't need more string theorists. And it's kind of like, okay, you said a decade, we don't see anything. But one thing they do, one thing the particle physicists do, is they look at this idea of supersymmetry and they're like, ooh, what if we had this but in particle physics? What if we had a supersymmetric extension of the standard model, you know? And should I do it? I'm not going to do it for that. And so particle physicists, without the string theorists, develop a supersymmetric version of the standard model. And because they're particle physicists and the standard model is a very successful theory of physics, they immediately develop an experiment to test this idea that they have, and they start getting funding for it, and they will test it in the next decade. That is, of course, in opposition to the string theorists who have not yet proposed experiment. And I'm sure you can find them proposing experiment, but the issue with the multi-dimensions is that if you don't get your expected result, you do have an answer, which is, oh, we just couldn't observe it this time. Like it wasn't in a dimension we could observe. And like that can't be your working model of physics. That just can't be. So that was the 90s. We can move to the 2000s. The string theorists, what do you know it? They're like, you know, we're a decade away from something amazing. And this is about when the multiverse idea starts getting very popular. Like not only are there multiple dimensions, but there are multi-universes that again, we cannot observe. And the string theorists, of course, they write their books and they get their money and they talk about the multiverses because of course people are interested in this idea. That's an exciting idea, even if it doesn't have any physics backing or experimental verification even possible. That is something that someone who's just a casual viewer of physics would be interested in learning about. So they write their books and they get their cash. What else? It's the 2000s. Oh, I have another book. Should I pause? This book. So the Einstein year happened in 1905. 2005, they did like a big 100th anniversary. This is Einstein's book that he republished a bunch of times, but this is like the last like 1940 something version. And because they're republishing it for the big Einstein year, they ask a big famous physicist, Brian Greene, to write the introduction. And I'll just read to you what he says. And remember, this is the year 2005, so he probably wrote this in 2004. But he talks about relativity and how it's a huge deal and how it was such a big thing with physics, and it was a revolution in physics. Oh my goodness, all the things that came from it. And Brian Greene says, again in 2005, he says, now this change from point particles to strings that are so small that they look like points might not sound like it would accomplish much, but it does. Superstring theory successfully merges general relativity and quantum mechanics. Now, does it? Does it, Brian Greene? Have you successfully? Because like, I actually think I would have heard about a giant test where you successfully merged quantum mechanics and general relativity, but you haven't, and you didn't. You lied. There's the George Costanza thing where it's like, oh, it's not a lie if you believe it, right? But did Brian Greene actually believe 20 years, 30 years into an untestable theory that string theory was going to come out on top? Did he think that? He wrote that like it was a fact. He wrote that like it was a true statement that all physicists would agree with. And I don't think so. We'll talk, I don't think so. Leonard Susskind in 2008 is like, the LHC is going to confirm supersymmetry. So the Large Hadron Collider, that's one of the experiments that the particle physicists had developed to test their supersymmetric extension of the standard model. Remember, of course, that is not a string theory. That is an idea that was taken from string theory and applied to the standard model. So it is not a string theory. It is a particle physics standard model theory. But Leonard Susskind, string theorist, is like, it's coming up gravy, baby. The LHC is going to test it, and that will be experimental verification of string theory. But that's not true, because spoiler alert, supersymmetry is dead in the water. But if it wasn't, if supersymmetry had been experimentally verified by the LHC, that would have been an extension of the standard model. It would have been experimental verification of that extension, and it would not have been anything to do with string theory besides that they got the idea from string theorists, right? But in the 2000s, they were kind of grasping for anything they could because the physicists had started really hampering on this idea of like, it's untestable, so is it even physics? If you go to the Wikipedia page for the history of string theory, it does in fact stop in 2003. So yeah. Something else that started happening in the 2000s with the string theorists is that they started getting publicly annoyed at kind of the lack of interest by the physics community, which is a thing that happens when you're a very famous physicist and you don't like the physics response to your stuff. You start complaining publicly. And the string theorists are like, we're like Galileo. No one is listening to us. They won't even look through the telescope. Big things are gonna happen in a decade. The physicists won't listen. So the public, of course, in the 2000s, here's the string theorists, they're boys saying this, and they're like, oh, it's Galileo all over again. The real physicists, the string theorists, are so brilliant, and it's like Einstein, and no one will listen to them. Oh my gosh, the physicists ignore the truth. The string theorists are gonna produce something amazing in the next decade, and then they'll all see, I hate physicists, but I sure do love string theory. And they watch their books, no, they watch their documentaries on Nova by the string theorists about the multiverse, and they read their books, and they're like, real physicists are a problem. The string theorists will prove them, you'll all see. And this, I think, upsets the physicists, the other physicists, the not string theory physicists. They're just like, I'm working so hard. Like, imagine you are a Swiss gentleman and you discover the first planet around an M-class star and you win the Nobel Prize in the 2000s and you're like, yay, exoplanets, hooray, people finally care about exoplanets. I won the Nobel Prize, yay. And then you go to give your interview with the reporter, and the reporter's like, yeah, exoplanet's very cool. How do you feel about string theory? And you have to be like, how do I feel about what? Like, I haven't even heard a talk about string theory in a decade. Who's doing string theory? Why are you bringing up this esoteric, old, untestable theory to me all the time? I just want to talk about exoplanets. And the reporters, they're like, but we love string theory. What about the multiverse, huh? And the physicists start being like, no, I don't want to talk about that. What are you talking about? And they're annoyed. They're annoyed. And in the 2000s, lots of books and stuff come out by other physicists who are like, string theory doesn't make any sense. You've been had. Stop listening to string theory. There's this thing, there's this quote from Wolfgang Pauli, who is a very famous physicist. He won the Nobel Prize. Ooh, do I even know? I don't even know what he won. It's something in quantum mechanics, you know, spin or something. I'll look it up and put it on top. Ooh, am I gonna edit this? I don't know if I will. Haha, you'll never know what Wolfgang Pauli won the Nobel Prize for. Wolfgang Pauli was like, he was like a character. And he is famous for like this story where someone presents him with a physics theory that is very poorly written and like kind of hard to understand. And he replies with, it's not even wrong, like as an insult. Like, the theory is so nonsensical that you can't even begin to disprove it. It is an insult because it's like, you didn't even take the time to write a good theory. I don't even have the time to explain why it's wrong. It's not even wrong. It's not even a theory. And people start taking this quote and applying it to string theory because, is it a theory? Remember the three things? I said you have to have a mathematical explanation for the universe, like physical laws, which string theory has. But you also have to explain all past observations, which string theory can do because they do have the answers. Remember I said the results of your math can pop up in different dimensions, but if you know what answer you're looking for, because you've already done the experiment, you can get that answer out of string theory. The part where string theory fails is that it doesn't make any suggestions for experiment. It doesn't have any experimental verification. It doesn't have like the way the standard model predicts particles. String theory has not made predictions like that. And if they have made predictions, they're not testable, which means they're not really predictions. So is string theory a theory? I mean, no, it's not. It's like a conjecture. It's like an idea for a theory. It's a mathematical tool, basically. And yeah, that's where we're at in the 2000s. It's kind of like the physicists are annoyed. They're annoyed that this keeps coming up. They're annoyed that their field is misrepresented in the media, and they're a little bit annoyed. And they're a little bit annoyed at the string theorists for allowing it to go this far. So we can move to the 2010s, and wouldn't you know it, the string theorists are like, we're a decade away from something amazing. You guys just wait. Now you have to realize, like, the number of string theorists has dwindled. The universities, I cannot imagine them ever hiring another string theorist, because like, it's just, if the field bears no fruit, it's not a great investment for your department to hire someone who's going to get tenure and be there for 55 years when they're doing something that doesn't have results. But you also see around this time is when the string theorists give their interviews, because they're still very famous and they're still like popular and people still like them, because of course these guys are great at explaining physics. They're great science communicators. If I don't agree with their methods, and I think it's been a harm to science communication overall, but they're good at their jobs. They start saying things like, well, because by this point, you know, by the 2010s, the public has heard the complaints from the other physicists, and they realize that, you know, this theory is not testable. And so the reporters know enough to know to be like, you keep talking about string theory, but the theory is not testable. What do you mean by that? And at this point, the physicists, no, the string theorists start adding on to their interviews like, well, I never said it was correct. I never said string theory was the right theory. I have hope for it. And Ed Witten has his quotes about it being a 21st century idea that fell into the 20th century, but now we're a decade in. No, I said it wrong. Ed Witten has his quote about string theory being a 21st century idea that fell into the 20th century, except now we're 30 years later and we're in the 2010s, and what have you done for me lately, string theory? Here we are, where's the ideas? And that's when Ed Witten starts saying things like, I don't know if we'll ever understand it. It's beautiful and I love it, but maybe we'll never understand it. Maybe we won't ever understand it. And at this point, I just have to say, like, how much, what is that called, where you have like so much time invested that you can't say no? Like, you can't just turn it off. It's like when you've been in a terrible relationship for like 11 years, but you can't be like, I've wasted 11 years, so you just stay in it forever. Yeah. But just wait, in a decade, they're gonna have the big results. Just wait. And 2010 is when the public turns on string theory. But they don't just turn on string theory, they turn on physics. This is the problem. This is the big problem. In the 2010s, these people, the people who read popular science books, the people who enjoy and like physics, realize that they have been scammed. They hear the professional physicists being like, wait, you don't even, no. They hear the professional physicists like not liking string theory, and their response is like, wait, you guys don't like string theory? Wait, you guys kind of like laugh at string theory? That's but I've been following it for 30 years. I've been waiting for the next big thing for 30 years. I've been telling my family about string theory results, and you guys don't even like it. It's not even a real physics theory. And they turn on all physicists. They say string theorists are liars. They've been saying wait 10 years for 30 years. And I think all physicists are liars. How dare they? And remember, the 2010s is when, I don't know if you guys remember, it's like for like the 10 years, they're trying to get these huge particle accelerators built. Like there was one in Texas, and the particle physicists were like, could we please have $200 billion to build a particle accelerator in Texas? And the public who's interested in physics is like, don't give those physicists any money to test their strings. They're liars. And the public doesn't understand that particle physics is not string theory. Particle physics uses the Standard Model, a very, very successful field of physics, to justify their experiments. Particle physics, linear accelerators, don't have anything to do with string theory, but the public has this connection in their head to physics is string theory because the physicists know, because the string theorists have been going on TV for 30 years and writing their books for 30 years and saying the future of physics is string theory, and I haven't been paying attention. I have no idea where to go. And it's a lie. It's a lie. The future of physics was never string theory, and they lied to the public for 30 years, and now when the public has to hear about other physics, they feel angry. They feel lied to because like they were lied to. And even though the particle physicists had their very successful theory and they wanted to build an experiment that, by the way, would work because they did find the Higgs boson in 2012, the public is like, don't give them any more money. We've been giving string theorists billions of dollars for decades and they've done nothing. And like the funding for the string theory was never very big. But like, you hear me. You hear what I'm saying. They're upset. They're upset and they associate all physicists with liars because they were lied to, not by all physicists, but they were lied to for a very long time. Okay, this book. God, don't read this book. Just don't read this book. This book is by a woman who talks to crackpot physicists, and she's like, I can understand crackpots because I have physics training, because she got like a BA in physics like 30 years before she wrote the book. Anyway, the book's so bad. I'm not going to do a book review. But the plot of the book is she's like basically in love with this one crackpot physicist he's just remaking the periodic table with like rings instead of particles. And she's enchanted by this idea. It's fine. It's just a regular crackpot dude. And she goes to a crackpot conference and she's like, I don't understand a thing these crackpots are saying. And then the big like mic drop of the book is she goes to a string theory conference in the 2010s and she's like, I don't understand what the string theorists are saying either. Multiple dimensions? That sounds crackpotty to me. And like the big conclusion of her book is that all physicists are crackpots. The physicists can't even explain their ideas to each other. And she's basing all physics on string theory, which obviously proves that she does not understand physics at all, even though she says she has a physics background. I hated this book. I hated it. I feel bad talking so bad about a book, but I hated it so much. I know she worked hard on it. It had some very nice pictures in it. It's fine. But she equates all physicists with string theorists, and she's like, well, I can't understand the string theorists, and I can't understand the crackpots. They sound just as stupid to me, so all of it must be the same. And that right there, the fact that she thinks that that's a big mic drop moment shows you how string theory messed up science communication. People think physics is string theory, even though this book was written in the 2010s and string theory came out in the 70s. And by like 1990, physicists were like, okay, we'll come back when you have something for me. And they haven't even dealt with it since. So it's the 2010s. The string theorists are like, just wait a decade. And the public is like, I'm done with string theory. And I actually have evidence for this because The TV show The Big Bang Theory came out in 2007. And in 2007, from my little decade by decade, I said the public was like, haha, all physicists hate the string theorists, the true physicists. And that show comes out and the main character is a string theorist, right? And that's his attitude. He's like, I'm better than all the physicists because I'm a string theorist. And the audience is supposed to watch that and be like, haha, I get it. That's my opinion too. But by the end of the show, which happens a decade later, string theory in the public eyes is now a joke. And in the public's eyes, physicists are stupid liars, and that's how they portray the character. Because the public opinion of string theory shifted in that timeline. That's my evidence for that. Okay, so now we have the physicists in the 2010s. And the physicists are kind of annoyed that they wasted all that time on supersymmetry, which yielded nothing. You know, because they did experiments and they ruled it out, you know, but that idea came from string theory. They just applied it to the standard model, and now they're like, well, the one thing you gave us was a big waste of time, but like, it's fine because null results are important and fine. And they now find themselves defending string theory in the media, which is what I will do for you now. Because the public went from this idea of like, we love string theory, it's the only good physics, to like, all physicists are liars and wrong. And so now if you say string theory to the public, they think that string theorists are like phonies and idiots. They think that string theory is a fake theory. And I mean, it's not a theory, but string theory is an actual mathematical tool. Like if you bought the textbook and you decided to learn how to do string theory, you could do it, right? It is a genuine mathematical theory, and you can answer physics questions you already know the answer to with it. And the string theorists are not dum-dums. They do know physics, and they are actually working on things. And it's not a fake theory. It's just a theory. Is it a theory? It's not a fake theory. We can call it a theory if you want. It's just that it's lost favor. It's lost its enchantment. But people still have enchantment for string theory, and some people still work on it, and that's fine. Because there's nothing wrong with working on bad ideas or ideas that won't bear fruit. I think it's good that funding goes to lots of different ideas, and I don't think string theory was a waste of time, right? If people got anything from it, if they developed a new understanding of the universe, I think that's fine. There's nothing wrong with doing an idea that doesn't bear fruit. There's nothing wrong if the experiment you set out to do gives you the answer you didn't expect. Like, that's good. That's how we learn, right? It's fine to do string theory. I mean, I wouldn't suggest that we fund string theorists, but like the fact that they spent 30 years on it, like that's fine. It's fine. They're not idiots. They didn't do anything wrong. That's how science works. My issue is with how they lied to everyone about it. That's my only issue. I don't care that people do string theory. It's fine. Like, I'm glad funding goes to lots of different things and people have different opinions. That's fine. My issue is the lying. So let's talk about the lying, because we don't even have to go to the 2020s because string theory has been dead since 2003. I'm gonna die. Why did I choose the most passionate talking point to be at the end? Oh no. Okay. My issue is with that they lied, right? For 30 years, string theorists gave interviews and wrote books where they said like, oh, in a decade, it's gonna be the next big thing. Did I win? I won. For 30 years. They're like, the next big thing. It's gonna be string theory. It's the next big thing. Just wait a decade. Wait, oh my God, it's gonna be the next big thing. In this book, Brian Greene is like, string theory did in fact combine quantum mechanics and gravity. And it's like, baby girl, that is a lie. That is not true. Maybe mathematically in your conjecture, that thing could work, but did we observe that? Did it happen in 2005? Did you think that that was the truth? No, you didn't. That is a lie. You can't write books for 30 years being like, just wait a decade. Oh my gosh, just wait a decade. Things are going to happen. It is a lie. It is a lie to give an interview where you're like, see, the problem with the standard model is that this happens and my theory fixes it. When your theory is not a theory and you don't have any experiments. It is okay to give an interview and say, here's what I'm working on. Here's what I think would happen when we test it. But you need to say when we test it. And again, Ed Whitten gives all these interviews and the interviewers are like, you're like Albert Einstein, huh? And he's like, no. Of course not. But it's just like, bro, how many interviews can you give where the interviewer asks you if you're Albert Einstein and then you see the press release where they call you Einstein and it's in the title of the article before next time you give an interview, you bring that up and you say, I'm not Albert Einstein, actually. Albert Einstein proposed experiments for his ideas, which were verified, his ideas, within like the decade. And it's been 20 years, actually. So I probably don't call me that, right? LOL. And then the reporter would understand. Have you seen Nan Olson's video where he talks about meta? And he talks about how the reporters, they don't have a handle on what like what is it? Virtual reality is, or what it will be like. So when the company gives them a soundbite that's like, in the next decade, 70% of time will be spent in virtual reality, they just take that as face value. They just take that as like, okay, they said this is true, right? So when you, the physicist, goes to an interview and you're like, in the next decade, we will have experimental verification of string theory, they take that as the truth. It doesn't matter if you didn't say that you think your theory is factual and correct, because if the writer writes that, if that's what they take away, that is what the audience gets. And it's okay if that happens one time, but for 30 years, these string theorists just let this misrepresentation of their ideas just spread through the public. It reminds me of Avi Loeb. Avi Loeb like writes a scientific paper where he's like, this thing's not a comet. This interstellar object is shaped like a solar sail or whatever. And then at the very bottom of that paper, he's like, you know, it could be artificial. It could be alien tech, maybe. And like that paper gets published by a scientific journal. And then Avi Loeb goes to a reporter and he's like, I published my findings in a journal where I said that aliens were real and I discovered them. And it's like, that's not what the article said. That's not what the community thinks. And you are misrepresenting yourself to an audience of people who are interested in science, and you are lying to them. The string theorists are lying. If every single interviewer calls you Albert Einstein and you're like, no, wouldn't you be embarrassed 30 years later when you're like not Einstein because there's no experimental verification? It reminds me of this, of M. Night Shyamalan. There was this magazine cover where he's like the next Spielberg, and like he didn't say that. They put that on his face. That wasn't up to him. But what if every single like magazine he was in said that and he didn't stop it? Like he did. He put a stop to it. He's like, I'm doing my own thing. I'm making movies, right? You can't, you don't have control over what the media writes. But if you are misrepresented for 30 years, that's your fault. And you lied. You lied to us. You lied. I'll give you an example from my own field. I'm a dark matter guy, but like I'm not anymore because I'm in industry where the cash is. But if I went to a conference and I was looking at the talks and my friend is like, should we go to this one? And then another person is like, hey, don't go to that one. He doesn't believe in dark matter. He's like a Mond guy. We would like laugh and we wouldn't go to that because I'm a particle dark matter guy. That's what I'm into. But because like I'm talking to the public right now, I will tell you that doesn't mean Mond is bad. That doesn't mean that Mond isn't a valid idea. Like, modified gravity as an answer to dark matter is interesting. And it's an interesting path to pursue, and I'm glad people are doing it. I personally, that's not my favorite, but like, I don't think they're wrong the same way they probably don't think I'm wrong. We just disagree on the best idea. And that's how science works, right? But giving an interview, I would never say, LOL, I would never go to a Mond talk. I would tell you factually that Like, I might not agree with Mond, but it's a valid idea. And I'm excited to see where they go with it, which is a true thing to say. I'm excited to see. I would never pretend that I have the answer because it is an open question. To go on Oprah and Conan for 30 years and be like, I have the answers and the answer is string theory was a lie. It's just a lie. I get that being Einstein and selling your books and your movies and going and giving talks and like being a famous scientist is like, it's pretty good for your career and also like for your cash flow. But it's kind of an egregious amount of lying for 30 years. All of them for 30 years are like, we're right and this is the theory and we're right and we're right and we're right and this is the theory. And now, of course, they're all like, well, I never said I believed in it. I just like the idea. But it's just like, you didn't say, maybe you didn't say you believed in it. Maybe. But you did go on the news and you let them say you believed in it over and over again. You can't make that mistake for 30 years and pretend that it was innocent and like, I never said I believed in it. But anyway, they lied for 30 years. And now we are in a space where science is not trusted. I don't know if you've seen that over the past 3 years especially, but I have had conversations with the public because like I do observing nights and stuff where someone comes in and they're like, you know, they don't actually know the density of Jupiter. They can't actually measure that. Like they're just saying stuff. And it's just like, we can measure the density of Jupiter right now. Like me and this person who said that, like we take a single image, we look up Kepler's laws, and we can measure the density of Jupiter and be really, really close. And that's beautiful and wonderful that physics has mathematical structure. We can make an observation and we can get an answer. That's what physics is. That is not what string theory is. And they lied for 30 years, and now all the people think string theory is physics, and we have to earn their trust back. And that sucks, man. Anyway, in this interview where Brent Green's like, I never said I believed in string theory. It was in 2021, and he was like, watch out, in the next couple of years, something's gonna happen. So maybe I'm wrong. We're gonna see. Let's just wait. Let's just sit on it for a decade, and we'll see who was right. Okay.